Hello everyone, this is Aditya, and today we're going to discuss a nice question which I found on social media that if x to the power 4 plus x cube plus x square plus x plus 1 is equal to 0, then find this value where alpha, beta, gamma, and delta are the roots of the given equation. So we have to find this value. So let's solve it. But before that, please do like, share, subscribe my channel, and please support this video. Now let's start with the solution. So let's solve this problem. On social media, I also found it's one of the solutions which many people give, but I think that that solution requires lots of remembrance of formula, which I don't recommend. In that, they stated that we should remember that x to the power n minus 1 will be equal to x minus 1 multiplied by x to the power n minus 1 plus x to the power n minus 2 and so on till x plus 1. So in that, they substitute n is equal to 5. So we get x to the power 5 minus 1 is equal to x minus 1, x to the power n minus 1 plus x to the power, n is equal to 5. So n minus 1 is 4 plus x cube plus x square plus x plus 1, right? And then when we will claim that if x is equal to 1, then x minus 1 will become 0 and x to the power 5 minus 1 will also become 0. So 0 is equal to 0, which means that x is equal to 1 is the solution of this equation, right? But we want that this expression to be equal to 0, right? Hence, if x is not equal to 1 and we want x over 4 plus x cube plus x square plus x plus 1 to be equal to 0, that means that this whole expression will become equal to 0. Since if this expression is 0, then it means that this RHS is equal to 0, right? Which implies that LHS will also be equal to 0. Hence, x to the power 5 minus 1 will also be equal to 0, correct? So it means that whatever roots this has, alpha, beta, gamma or delta, it should all be satisfied over here also. Hence alpha to the power 5 minus 1 will be equal to 0, beta to the power 5 minus 1 will be equal to 0, gamma to the power 5 minus 1 will be equal to 0, and delta to the power 5 minus 1 will also be equal to 0, right? Hence alpha to the power 5 is equal to 1, beta to the power 5 is equal to 1, and gamma to the power 5 is equal to 1, and delta to the power 5 is equal to 1. So from this solved this question. But I don't recommend this method. Why? Because in this you have to remember this formula, right? So I will tell you a method which you can apply in which you don't need to remember anything. You can solve it logically. So let's see that method, right? So the given equation is x to the power 4 plus x cube plus x plus 1 is equal to, sorry, x square plus x plus 1 is equal to 0. Okay. Let's multiply both sides by x, right? Let's multiply it. So we get x to the power 5 plus x to the power 4 plus x cube plus x square plus x is equal to 0, correct? Okay, now notice that this is also equal to 0, so you can say it equal to x to the power 4 plus x cube plus x square plus x plus 1, correct? Correct or not? It is correct. Clearly it is correct. So x to the power 4 gets cancelled with this, x cube gets cancelled with this one, this and this gets cancelled, this and this gets cancelled. So from this we get x to the power 5 is equal to 1, correct? And there's a similar expression which we got previously, right? But in this you don't need to remember any formula. You just applied a concept that let's multiply by x. And how I thought this? I thought that if I multiply both sides by x, then I can claim that this will become x to the power 5, this will become x to the power 4, this will become x cube, x square and x. So I see that x and x square, x cube and x to the power 4, they will be common in that expression, right? So from that I got an idea that yeah, I can subtract in that case. What I've done is that x to the power 5 plus x to the power 4 x cube plus x square plus x was equal to 0. And we had this expression also, right? We can write it like this also. X to the power 4 plus x cube plus x square plus x plus 1 is equal to 0, right? I just shifted it by one term, right? Now I subtracted it. So this gets cancelled, this, and this, and this, right? So we are left with is equal to 0. Correct? So now it has roots alpha, beta, gamma, and delta, right? Correct? Okay. So alpha to the power 5 is equal to 1, right? And beta to the power 5 is equal to 1, gamma to the power 5 is equal to 1, delta to the power 5 is equal to 1, right? So notice that we have the power 2021, right? So 2021 can be written as 202, I mean 2020 plus 1, which is equal to 5 times 404 plus 1, correct? So let's raise both sides to the power 404. So alpha to the power 5 raised to the power 404, it becomes alpha to the power 2020, which is equal to 1. Similarly, beta to the power 2020 is equal to 1, and gamma to the power 2020 is equal to 1, and delta to the power 2020 is equal to 1. Correct? I just raised both sides to the power of 404. 1 to the power 404 is again 1, right? Now we want 1 also, so let's multiply both sides by alpha. Here we will multiply by beta, here we will multiply by gamma, and here we will multiply by delta. So we get alpha to the power 2021 is equal to alpha. Similarly, beta to the power 2021 is equal to beta, and similarly for gamma and delta also. So basically this expression is equal to alpha plus beta plus gamma plus delta. Now what is sum of roots? In this case it will be equal to minus b upon a. So it will become minus 1 by 1, which is equal to negative 1. Do you know this formula? So let's assume a general polynomial a n x to the power n plus a n minus 1 x to the power n minus 1, and so on till a0 x to the power 0, that is just constant value, it is equal to 0. Then that case, suppose it has roots alpha 1, alpha 2, and so on till alpha n, right? You know it. So sum of the roots alpha 2 till alpha n, it will be equal to negative a n minus 1 by a n, right? So similar is the case over here also, right? So it will be equal to negative 1, right? Understood? Yeah. So the answer of this problem is equal to negative 1, right? So I hope that you enjoyed this video. If you did enjoy this video, then please do like, share, subscribe my channel, and bye bye, take care, and all the best.